Good morning, dear students. I am NSR, lecturer in chemistry, Vesvadeja Degree College, Penugonda. In this video session, we will discuss the syllabus for second BSc, third semester chemistry syllabus. The third semester chemistry syllabus will contain two parts. The first part containing inorganic chemistry and the second part containing the organic chemistry. In Unit 1, there are two chapters. First one is the chemistry of D block elements and second one is the theory of bonding in metals. Already in our previous classes, we will discuss about the D block elements. In this lesson, we will discuss the special properties of the D block elements, generally special reference to the electronic configuration of the D block elements and as well as the variable oxidation states of the D block elements and also the magnetic properties, catalytic properties and ability to form the complexes. Okay. These are the special properties of the D block elements. These 5 properties will be discussed in this chapter and also we will explain the stability of the variable oxidation states of the D block elements. It is the first lesson, belongs to first unit, and the second chapter of the first unit is theories of bonding in metals. In this lesson, we will discuss the metallic properties and its limitations. In order to explain the metallic nature, the 3 fundamental theories are proposed. First one is the valency bond theory, and second one is the free electron theory, and third one is the molecular orbital theory, that is band theory. These 3 theories are completely discussed in this chapter, and also we will explain the thermal and electrical conductivities of the metals. These 2 chapters are belongs to the first unit. Whereas in case of second unit, it will also contain the 2 chapters. First one is the metal carbonyls and second one is the chemistry of the F block elements. In metal carbonyls, we will discuss the EAN rule, F2 atomic number rule. First of all, what is meant by F2 atomic number? How the EAN will be calculated will be discussed, and then we have to learn about the classification of the metal carbonyls. Generally, the metal carbonyls are classified into 2 types. First one is the mononuclear metal carbonyls and second one is the polynuclear metal carbonyls. This classification of the metal carbonyls will be discussed in this chapter, and also we will discuss the structure and shapes of the metal carbonyls, especially vanadium, chromium, manganese, iron, cobalt, nickel. These metal carbonyl shapes and as well as the structures will be discussed in this chapter. And the second chapter in this unit is chemistry of F block elements. Already we know that the F block elements are placed at the bottom of the periodic table. It will contains the 2 series. First one is the lanthanides and second one is the actinides. In this session, first of all, we discussed about the chemistry of lanthanides. In this, the electronic configuration of the lanthanides will be discussed and the exhibitance of the variable oxidation state of the lanthanide elements and also magnetic properties of the lanthanides will be discussed. And the second part in this chapter is actinides. Okay, in this chapter, in this part, we will also discuss about the what is actinides, what are the electronic configuration of the actinides, how it show the variable oxidation states, and magnetic properties will be discussed. In this chapter, an important topic will be learned, that is lanthanide contraction. What is lanthanide contraction? What are the causes and consequences of the lanthanide contraction will be discussed in this unit. And finally, the separation of lanthanides by ion exchange method and as well as the solvent extraction method will be discussed in this chapter. These are the units which are belong to the inorganic chemistry. that is unit 1 and as well as the unit 2. And next part is organic chemistry. In organic chemistry, there are 3 units. In the first unit, there are 2 chapters. First one is the halogen compounds and second one is the hydroxy compound. In halogen compounds, we'll learn what are halogen compounds, how the halogen compounds are classified, and we will discuss the nomenclature of the halogen compounds. In generally, the halogen compounds are more suitable about the nucleophilic substitution reactions, that is SN1 reaction and as well as the SN2 reaction, unimolecular nucleophilic substitution reactions and as well as the bimolecular nucleophilic substitution reactions. These are the most common reactions in the halogen compounds, that is alkyl halide. It will be discussed in this chapter. The SN1 reaction mechanism and as well as the SN2 reaction mechanism are specially discussed by taking ethyl chloride and as well as the tertiary butyl chloride as the example. In the second chapter, the title is hydroxy compound. In this, we learned about what are hydroxy compounds. Generally, we know that the OH group is attached to the alkyl group is called as the hydroxy compounds. Depending upon the alkyl group, that means nature of alkyl groups. The alkyl group is aliphatic, then it is called as the alcohols, and the alkyl group is aromatic, then it is called as the phenols. That will discuss in the hydroxy compound. First of all, we will discuss the nomenclature and as well as the classification of the hydroxy compounds. These hydroxy compounds are 2 types. First one is the alcohols and second one is the phenols. In alcohols, the OH group attached alkyl group is aliphatic, then these are called as the alcohols. The preparation of alcohols by suitable methods, that is hydroboration reaction and from Grignard reagent will be discussed. Next, second one is the phenols. In this phenols, the preparation of phenols from diazonium salt and as well as the aryl sulfonates and as well as the cumin will be discussed. The physical properties of the alcohols and as well as the phenols, the hydrogen bonding will be discussed, and also the identification of alcohols by the oxidation of KMnO4 and as well as the steric ammonium nitrate and locus reagent will be discussed, and the identification of phenol by neutral FeCl3 will also be discussed in the hydroxy compounds. And finally, in this lesson we have to discuss about the chemical properties of alcohols and as well as the phenols. Whereas in case of alcohols, dehydration of alcohols will be discussed and the oxidation of alcohols by CrO3 and KMnO4 will also be discussed. And finally, the special reactions of phenol, that means the chemical properties of phenol like bromination, Kolb-Smith reaction, Raymer-Thielman reaction, Fries rearrangement, azo-coupling reaction and as well as the penacol-penacolone rearrangement will be discussed in hydroxy compound. Next, the fourth unit is a carbonyl compound. Already we know that the carbonyl compounds are 2 types. First one is the aldehydes and as well as the ketones. In this lesson, first of all, we have to discuss the nomenclature of aliphatic and as well as the aromatic carbonyl compounds and the structure of the carbonyl group and the synthesis of aldehydes and ketones by using special reagent like acid chlorides and 1,3 dithiones and nitriles and carboxylic acid will be discussed in this chapter. And then the physical properties of the aldehydes and as well as the ketones will be discussed. Generally, these carbonyl compounds are more suitable in the nucleophilic addition reactions. These nucleophilic addition reactions will be discussed in this chapter. And